It weighs more than a school bus. It costs as much as a house in a good neighborhood, sometimes several. It can carve a titanium jet component to tolerances thinner than a human hair, running all night in a dark factory with nobody watching. And buried inside its electrical cabinet is a small sensor with one job. If anyone moves this machine without permission, it kills itself. The controls lock. The spindle goes silent. Millions of dollars of precision engineering becomes a block of iron that will not wake up without an encrypted password issued from a headquarters in rural Japan, and only after a certified technician physically confirms where the machine is sitting and who is using it. This is the story of Mazak. You're watching Trade Archive, where we dig into the companies that quietly run the world. If that sounds like your kind of story, hit like and subscribe before we go any further. Nagoya, Japan, 1919. Japan in 1919 was a country remaking itself at breathtaking speed. The First World War had just ended, and while Europe burned through 4 years of destruction, Japanese industry had spent those same years selling to the world, growing richer and more capable with every shipload. Railways were pushing into the countryside. Electric power was reaching towns that had run on lamplight a generation earlier. For an ambitious man with mechanical skill, there had never been a better moment to start building things. And few places felt that momentum like Nagoya. For centuries, it had been a castle town sitting between Tokyo and Osaka, a city of merchants and craftsmen. Now it was filling with workshops, mills, and foundries, on its way to becoming the manufacturing heart of the country. One of those ambitious men was Sadakichi Yamazaki. That year, in Nagoya, he opened a small workshop called Yamazaki Machinery, a business he would lead himself for the next 43 years through boom, depression, war, and rebirth. And he wasn't building anything glamorous. His company made equipment for weaving tatami, the traditional straw mats that covered the floors of nearly every home in Japan. Tatami were woven from rice straw and rush grass, and weaving them by machine instead of by hand was exactly the kind of practical mechanization a growing country wanted. Millions of households, every one of them standing on mats that wore out and needed replacing, which meant a steady, dependable market for the machines that wove them. It was humble, reliable work, the kind of business a man could run for 50 years without anyone outside his neighborhood ever learning his name. Sadakichi had other plans, because while his workshop turned out mat-weaving machinery, he was watching something much bigger unfold around him. Factories were going up everywhere, railroads were spreading, and every one of those new factories needed machines. So Sadakichi began to climb, one rung at a time. And if you trace his choices across those years, you can see how the man thought. He never bet the company on a fashion. He followed his country's needs up the value chain, step by patient step. When Japan needed homes, he built machines for the mat makers. When Japan started building in earnest, he moved into woodworking machinery and equipped the carpenters of a construction boom. Business grew, and in 1923 he built a new, larger factory in the Yatsuda district of Nagoya to keep up with it. And it was inside that factory that the company's real future revealed itself, almost by accident. To build its own products, Yamazaki Machinery needed precision equipment, lathes and milling machines that could shape metal accurately. Rather than buy them, Sadakichi's workshop made its own. A lathe, if you've never stood in front of one, is a machine that spins a piece of metal at high speed while a cutting tool shaves it into shape, and the whole game is precision, holding a dimension to a tiny fraction of a millimeter, hour after hour, cut after cut. It is not easy to build a machine that can do that. Sadakichi's shop could, and those in-house tools turned out to be so well made that other companies started asking to buy them. Think about what that says. The machines Sadakichi built just to satisfy his own standards were good enough that his customers wanted them more than his actual products. He took the hint. In September of 1927, Yamazaki Machinery formally entered the machine tool business, building lathes and milling machines for sale. A year later, In 1928, the company completed its first commercial machine tool, a lathe, delivered, as the story goes, to a local sewing machine maker. By 1931, it had moved into full-scale machine tool production. And in 1934, it developed its first motor-driven roll lathe, a serious piece of heavy industrial equipment that announced the company as a real player in Japanese manufacturing. Here's what makes a machine tool different from every other product on Earth, and why this moment matters so much. A machine tool is a machine that makes other machines. The engine block in your car was carved by one. The landing gear on the last plane you flew in was carved by one. The titanium hip implant in your grandmother's leg was carved by one. Every physical object in the industrial world traces its ancestry back to a machine tool somewhere. That's why the industry calls them mother machines. Control the mother machines, and you sit at the source of everything. In 1927, in a factory in Nagoya, Sadakichi Yamazaki had planted his company at that source. And through the 1930s, business surged. Japan's heavy industries were expanding fast, demand for machinery kept climbing, and Yamazaki scaled with it, growing its output year after year. By 1939, the company had established its own dedicated sales department. In 20 years, the mat weaver's workshop had become an established name in Japanese heavy industry, with a growing reputation and a future that looked unstoppable. And then, the future arrived carrying incendiary bombs. Through the late 1930s, Japan's economy was pulled deeper and deeper into the war effort, and industrial cities like Nagoya were pulled hardest of all. Because during the Second World War, Nagoya wasn't just another Japanese city, it was the center of the country's aircraft industry. Mitsubishi built planes and engines there, and according to the United States Strategic Bombing Survey, somewhere between 40 and 50% of Japan's combat aircraft and engines came out of Nagoya's factories. The Zero fighters that struck Pearl Harbor traced back to this city's production lines, which meant that when American bombers came for Japan's war machine, they came for Nagoya, and they kept coming. The first major raid hit on December 13, 1944, with the city's aircraft plants among the first priority targets when the B-29s arrived. Over the following 7 months, Nagoya was attacked 21 times, more than any Japanese city except Tokyo, and the campaign escalated from precision strikes on factories to the firebombing of the city itself. By the survey's own count, more than 14,000 tons of bombs fell on Nagoya in the final 9 months of the war. In March of 1945, entire districts of wooden homes and workshops burned in a single night. And in the raid of May 14, 1945, the fires reached Nagoya Castle itself, and a landmark that had stood for over 3 centuries burned to the ground in an afternoon. For the Yamazaki family, the consequences were brutal. Everything the company depended on, its buildings, its equipment, its customers, its city, sat inside one of the most heavily targeted zones of the entire Pacific War. By the surrender in August of 1945, the industrial city that Sadakichi had spent 25 years growing into was a field of ash and twisted steel. Think about what that means for a machine tool company. Your customers are factories, and the factories are gone. Your suppliers are gone. Your country's economy has collapsed into hyperinflation and shortage. There is no venture capital coming to save you. There is no government bailout. There is only rubble and the question of whether you have the will to start over. The Yamazaki family had the will. And in May of 1946, less than a year after the surrender, a young man walked into what remained of the business. His name was Teruyuki Yamazaki. He was Sadakichi's son. And over the next 6 decades, he would take this workshop in a defeated nation and turn it into one of the most powerful manufacturing companies on the planet. Nobody could have seen that in 1946. Starting over meant more than clearing rubble. Like every industrial firm in occupied Japan, Yamazaki had to pivot from an economy organized around war back to ordinary commercial work, finding peacetime customers in a country where almost nobody had money to spend. The late 40s and early 50s were years of grinding, unglamorous recovery. There were no breakthroughs to celebrate, just the slow work of restoring production, winning back customers one order at a time, and holding on to the engineering standards that had made the company's name before the war. Father and son rebuilt together, Sadakichi with 30 years of hard-won experience, Teruyuki with the energy and ambition of a new generation. And slowly, the country itself began to lift. Japanese industry found its footing again through the 50s, and as the economy recovered, so did demand for the one thing Yamazaki knew how to make better than almost anyone: precise, dependable machines. In 1959, all of that patience finally produced something worth waiting for. Yamazaki launched a new line of high-speed, high-precision manual lathes, the LA, LB, LC, and LD series. These were not exotic machines. They were fundamentals executed to an exceptional standard, lathes a machinist could trust to hold accuracy, shift after shift, year after year. And in an industry where a reputation takes decades to build and one bad machine to lose, that reliability was worth more than any invention. The new lathes rebuilt the company's standing from the ground up, and they sold. For the first time since the war, Yamazaki machinery wasn't just surviving, it was winning. And Teruyuki was already looking past Japan's borders. In 1961, three things happened that set the course for everything that followed. In May, the company shipped its first machines overseas, 3 LD series lathes bound for Indonesia. 3 lathes. It doesn't sound like much, but it was a test, and the test worked. In October, a new plant began operating in Oguchi, a town outside Nagoya. That plant gave the company room to scale, and it has anchored the business ever since as the headquarters of a global operation. And in November, Yamazaki joined the Japan Machine Tool Builders Association, planting its flag among the country's industrial elite. Exporting a machine tool is nothing like exporting radios or textiles. A machine tool is a 20-year relationship. The customer needs parts, service, and trust, and they need to believe the maker will still exist decades from now. For a Japanese builder in 1961, asking foreign machinists for that kind of trust, 16 years after the war, took genuine nerve. Then, in June of 1962, the company did something no Japanese machine tool maker had ever done. It landed a contract to export 200 LE series lathes to the United States of America. It was the Japanese machine tool industry's first large-scale export to the American market, and it was an act of almost absurd ambition. In 1962, America was the undisputed king of machine tools, the country that had outproduced the entire world during the war. And here was a company from a defeated nation, a company whose home city had been bombed into rubble 17 years earlier, shipping 200 machines straight into the king's backyard. 200 machines was not a toe in the water. It was a full commitment of the company's production and its reputation to the most demanding customers on Earth. If those lathes failed in American shops, the Yamazaki name would be finished there before it had even begun. Sadakichi Yamazaki lived just long enough to see it happen. He died in September of 1962, at the very moment his company was breaking into the biggest market on Earth. Consider the full arc of that life. He had opened his workshop in the year the world signed the peace ending the First World War, watched his city burn in the Second, rebuilt from nothing, and lived to see his lathes ordered by the hundreds in America. He had started with straw mats and ended at the doorstep of the industrial world's greatest power. And the industry never forgot him. Decades later, in the year 2000, the American trade journal American Machinist inducted Sadakichi Yamazaki into its Hall of Innovators, honoring the mat machine maker from Nagoya as one of the industrial pioneers of his era. 1 month later, in October, Teruyuki formally took over as president. He was the second generation, and he inherited a company at the most important crossroads of its life. Teruyuki, who his American partners would come to know simply as Terry, ran the company on a conviction that would define the next 50 years. A machine tool maker doesn't sell from a distance. It shows up, it stays, and it earns its place inside its customer's world. One of his first major moves tells you everything about how he thought. In May of 1963, Teruyuki announced a new brand name for the company's machines. The problem was simple. Western customers found the name Yamazaki difficult to pronounce and easy to forget, and a name nobody can say is a name nobody asks for. So he compressed it into something short, sharp, and international: Mazak. The name itself was the strategy, short enough for any language, distinctive enough to remember, stamped on every machine that left the factory. It was a small decision on paper and a massive one in practice, because Teruyuki wasn't planning to be a Japanese company that occasionally exported. He was planning to compete everywhere, against everyone. 2 years later, in 1965, he moved the company's headquarters to the Oguchi plant, putting management and manufacturing under one roof. The infrastructure followed fast. In July of 1968, the company established Yamazaki Machinery Corporation in New York, its own American subsidiary. Most Japanese manufacturers of that era sold overseas through trading houses, middlemen who moved the boxes but knew nothing about the machines inside them. Teruyuki refused to work that way. If Mazak was going to sell to American machinists, Mazak would stand in front of American machinists itself. And while the sales network grew, the machines themselves were crossing a technological frontier. In September of 1968, Mazak developed its first numerically controlled lathe, the MTC series. Numerical control meant the machine's movements were directed by coded instructions instead of a craftsman's hands. It's hard to overstate that shift. For a century, the quality of a machined part had depended on the touch of the person at the handwheels. Numerical control moved that skill into the program, which meant one expert's knowledge could run 100 machines. And remember what computers looked like in 1968: room-sized, punch card-fed, and rare. Putting coded control onto a factory machine in that era placed Mazak at the leading edge of what manufacturing could do. The company kept pushing. In 1970 came its first machining center, the BTC No. 5. And in 1971, it built the MTC 1500R AC, Japan's first adaptive control lathe, a machine that could sense its own cutting conditions and adjust itself in real time. In barely a decade, Mazak had gone from manual lathes to machines that corrected their own work. But Teruyuki's boldest move was still coming, and it would land in the middle of Kentucky. In July of 1974, Yamazaki Mazak completed something that made almost no sense to its competitors: a full manufacturing plant in the United States. And this wasn't a sales office or a warehouse. It was a working factory, building Japanese-designed machine tools on American soil with American workers, which made Mazak one of the very first Japanese machine tool builders to ever manufacture in the United States. The decision was unconventional, to say the least. Japanese exports to America were booming, and the obvious play, the play every competitor was running, was to build everything in Japan where you controlled costs and ship it across the Pacific. Building in America was expensive, complicated, and risky. And in 1974, plenty of American buyers still doubted Japanese engineering. If the quality slipped, the doubters would be proven right. But Teruyuki believed something his rivals didn't. He believed that a machine tool company had to live close to its customers, inside their manufacturing culture, or it would never truly understand them. The location was no accident either. Northern Kentucky sat within reach of the machine shops of Ohio, Indiana, and Michigan, and Greater Cincinnati gave the plant logistics, suppliers, and a workforce that knew factories. So he planted his company in a town best known for a water tower that famously reads Florence Y'all. If you know how that tower got its name, comment below. And Kentucky wasn't a one-off. Mazak put down roots in Belgium in 1975 and in the United Kingdom in 1980, assembling a genuinely global company while its rivals were still shipping crates from home. The Florence plant has since been expanded 20 times, growing to nearly 1 million square feet. And in 2024, Mazak celebrated 50 years of manufacturing in America. In August of 2025, the plant completed its 40,000th Kentucky-built machine. Half a century after Teruyuki's gamble, the factory is still running. And 12 years after it opened, that gamble paid off in a way even Teruyuki couldn't have fully predicted. By the mid-1980s, Japanese machine tools had gotten so good and so affordable that they were tearing through the American industry. Historic U.S. manufacturers were collapsing, Washington erupted, and by December of 1986, the Reagan administration had pressured Japan and other countries into restraint agreements that capped machine tool imports for 5 years. But import restrictions restrict imports, and machines built in Florence, Kentucky by American workers were not imports. While the industry fought over quotas, Mazak's American plant kept building, selling, and growing, protected by a factory that had stood since 1974. The Kentucky bet turned out to be one of the great defensive moves in manufacturing history, even though it was never designed as one. It was designed as something better, a genuine commitment to the market. And while all of this was unfolding in America, Mazak's engineers back in Japan were changing what a machine tool even was. First, know what programming a CNC machine used to feel like. You wrote in G-code, a dense language of coordinates and commands, calculated tool paths by hand, and in many shops, punched the program onto paper tape. One wrong digit could send a spinning cutter crashing into the workpiece, and skilled programmers were rare, expensive, and permanently overworked. In June of 1981, Mazak ended all of that with the Mazatral T1, the world's first conversational CNC system for lathes. Instead of demanding code, the control asked questions in plain language. What is the raw material? What diameter? What shape does the finished part need? The operator answered, and the control selected the tools, calculated the paths, and set the speeds, so a machinist with no programming background could produce a complex part in minutes instead of hours. It opened advanced manufacturing to thousands of small shops and became one of the most important productivity breakthroughs in the industry's history. The hardware kept pace, too. That same year, Mazak launched its quick-turn CNC lathes, a line still in production today, and a year earlier it had begun selling slant-turn lathes that could mill as well as turn, the first step towards something much bigger. And 1981 was not finished. That October, at the Oguchi headquarters, Mazak switched on its flexible manufacturing factory, where machines produced different parts overnight, from 10 at night until 6 in the morning, with nobody on the floor. Unmanned manufacturing, in 1981, drew attention from around the world. The same year, the company adopted the slogan, "It still carries, together success." In 1985, the parent company renamed itself Yamazaki Mazak Corporation, and by 1987, its European plant in Worcester, England, was running full computer-integrated manufacturing. Quick pause. If you're enjoying this one, do me a favor and hit subscribe. Trade Archive is built on deep dives like this one, into the industrial giants nobody makes videos about, and subscribing makes sure the next one reaches you. Now, everything so far was building toward the machine Mazak is known for above all others. For most of manufacturing history, making a complex metal part meant a relay race between machines, and every handoff cost time, floor space, and a little bit of precision. Those slant-turn machines of 1980 had been the first step. But in September of 1997, it unveiled the full answer, the Integrex 200Y, which fused a high-powered CNC lathe and a full milling machine into a single body. Mazak called the philosophy done in one. The main spindle turns the part. A milling head sweeps in to drill and carve, and the machine passes the part in mid-air to a second spindle to finish the backside, with nobody ever opening the doors. For aerospace, medical implants, and semiconductors, lead times measured in weeks collapsed into hours. 2 years later came the Vari-axis line, machining centers cutting on 5 axes at once, and the family has since grown to include the Integrex AG series for gear cutting and hybrid machines that combine machining with 3D metal printing. But there's a shadow that follows technology this powerful, because a machine that can carve anything doesn't ask what it's carving. Remember the machine from the beginning of this video, locking itself down on the back of a smuggler's truck? This is where that story starts. The most advanced machine tools are what governments call dual-use technology. The same precision that makes a surgical implant can make centrifuge rotors for enriching uranium, and a machine that can carve a submarine propeller's complex curve can make that submarine far harder for an enemy navy to find. That's why they're wrapped in some of the strictest export control laws on Earth. Japan learned how badly this can go wrong through hard experience. A Cold War scandal, one we'll come back to at the end of this video, had already shown the world how exported Japanese machines helped quiet Soviet submarines. Then, in 2006, investigators raided the measurement company Mitu Toyo and found it had rigged its own software to slip ultra-precise equipment past export inspections, equipment that reached Libya's nuclear program. Executives were convicted, and Japan's export control regime tightened hard. Every Japanese machine toolmaker felt that pressure, and Mazak did something no one else had done. In early 2008, the company announced that every machine it shipped, worldwide, would carry a relocation detector, a sensor system installed in the electrical cabinet. If the machine is moved from its registered installation site, it triggers an alarm and shuts itself down. Completely. It will not run again until its location is verified, and Mazak itself issues a new password. And this wasn't a policy handed down by regulators. Trade press at the time described it as a personal initiative of Tomohisa Yamazaki, the company's third-generation president, and Brian Papke, who led Mazak's American operations, said, "We believe this industry-leading action is the right thing to do." Every machine, no exceptions. The threat never went away. After Russia's full-scale invasion of Ukraine in 2022, sanctions banned advanced manufacturing technology from reaching the Russian military. Yet open-source investigations in 2023 and 2024 documented Western CNC machines inside Russian weapons production, Mazak's among nearly every major makers, the machines passing through chains of third-country intermediaries until their origin blurs. There is no evidence that Mazak knowingly sold to any sanctioned buyer. That is precisely the point. The relocation detector exists because the company understood, earlier than almost anyone, that the world's best machines will always be hunted. The company that carries that burden today runs factories its founder could never have imagined. Since 2015, Mazak's plants have operated as what it calls iSmart factories, where every machine streams live data and maintenance happens before failures instead of after, and Pallotech, the automated pallet system Mazak has built since 1993, feeds production through the night with the lights off, the direct descendant of that unmanned experiment from 1981. Mazak partnered with Cisco to build the SmartBox, a hardened gateway that walls its machines off from hackers, and its optronics division builds industrial laser cutting machines. The Mazatral control never stopped evolving either, fusing with Windows PCs in 1998 as the Fusion 640 and arriving in 2019 as Mazatral Smooth Eye, running artificial intelligence and writing machining programs straight from a 3D design. 100 years ago, this company made machines for weaving straw mats. Today it employs roughly 8,700 people, runs 11 plants across 6 countries, and remains what it has always been: a private, family-owned business, 4 generations deep, still headquartered outside the city that burned around it in 1945. Mazak never became a household name, and it never needed to. Its machines sit behind the doors of the factories that make everything you own. That was Sadakichi Yamazaki's real insight, all the way back in 1927. Instead of making the products the world wants, you can make the machines that make them, and then the world has no choice but to come to you. If you made it this far, give the next video a watch. It's on your screen right now. Click it, and if you haven't yet, subscribe so you don't miss what we dig up next.